Okay, we're going to take a few notes on braking distance and sort of sum up what we found out with our lab yesterday. All right, so for part A, the first variable we looked at was speed, right? Okay, so when speed increases, what happens to your braking distance? What did your data tell you in part A? Yes, your braking distance also increases, right? Good. So you need a farther to stop when you're going faster. So the faster you go, the more distance. And remember, braking distance is only when you apply the brakes. It does not include your reaction time or anything like that. It's just from the minute you push the brakes. How long does it take your car to stop? And the faster you go, the more distance it takes. All right, and then the other variable we talked about in our lab was mass. Okay, so when mass increases, how does that affect your braking distance? What? Well, what happens to the distance? Longer, okay? Your braking distance is longer. So again, your braking distance increases. All right, and then we could flip this, right? What if we said when speed decreases, what happens to your braking distance? Decreases, right? Or when mass decreases, your braking distance decreases, okay? So you could flip it too. Either way. All right, so the last thing I want to make sure we understand is that your braking distance is going to be different than your total stopping distance, right? Okay, and we learned that when we did activity 14, when we were calculating the reaction times and then figuring out adding the braking times. Okay, so let's just write down a formula. So your stopping distance, which is the total distance it takes for you to come to a complete stop, equals your reaction distance, which is affected by how alert you are, right? Okay, if you're distracted as a driver, but remember your reaction distance is how far your car is going to go while you're reacting. Okay, so while you're reacting, so for you to notice what's going on, for the message to get to your brain, and then eventually send a message to your foot to push the pedal, that's all reaction distance. And your car can go pretty far while you're reacting. And then you add that to your braking distance. Which then is going to be affected by speed and mass. So there's a whole lot of things that affects your stopping distance total, isn't there? Reaction time, slippery roads or road conditions, weather, speed, mass, okay? So stopping distance is affected by many variables. And you have to keep those variables in mind, okay? Especially when we're trying to choose which car is the safest.